We're live.
We're live, yes. Good afternoon. What I want you to do is skip ahead to 21 and do 21. We're not going to do all of these today, so we'll probably not do 20. So we're going to pick and choose our way through this a little bit. What pattern do you have to remember for this? Remember, Will's not here with us. 1, 3, 5, excellent.
I got it.
1, 3, 5. Very good.
So how mad were you this first period whenever Lily got cupcake on
I
face?
know, it was just like, I wasn't really angry, but it's sort of like, that's not the kind of thing that you want to see as proper decorum in a classroom. Somebody smashing a cupcake into somebody's face.
Especially first period.
It was for her birthday, and she had, and so that was all. And so I was debating how I would handle it, like disciplinary wise, and I thought, nah, I could call them, no. But I'll tell you what I'm going to do. When she's getting ready to get married, I'm going to warn her husband. Is what I'm going to do. Hannah. Right, that's what I should do, right? Warn her husband. And what happened? I don't think any harm, but possibly harm could be done, right? Something could be in the eye, or she had some stain on her.
It's still stained.
It's still stained a little bit. She's going to be okay. We're going to be okay, but it's just like, that's not the kind of thing I want to see go on in my classroom,
Washed her face
especially.
5 times already. That's a couple.
Yeah. And she's okay. I mean, and they're friends. It wasn't really intended to be a harmful thing. It was just supposed to be like a practical joke prank thing. So to say I was really mad about it, man, that's just not what I wanted to see in my classroom. You know what I'm saying, right?
What's happening? I'm confused.
Lily got a
cupcake smashed in her face. Mr. G, contact.
Yeah, right in my classroom, sitting right down there where Hannah's
Mr.
seated.
G, in our generation, that's a symbol of affection.
Well, I realize that, but also I'm seeing I gotta sometimes look at it like a lawyer. Okay, I'm married to an attorney for one thing, and that what could possibly go wrong with that?
Maybe next time, close your eyes and don't see it.
Yeah, that's possible too. Okay, Emily just recommended I close my eyes to not see it. Everybody seen like the old sitcom in the 60s, Hogan's Heroes?
Yes.
Sergeant Schultz, I know nothing, I see nothing, because all the POWs are doing all crazy things, and he said, I see nothing, I know nothing. I could do that, right? Would that be a good thing to do? Sometimes that is. Sometimes ignorance is bliss.
So are you gonna leave this rant in the video?
Pardon me?
Are you gonna leave this rant in the video?
I might. It just depends which one I do. Now, it so happened that 5th period class was a good class too.
No, thank you. You need yours.
But I don't think we said anything. We didn't say anything that I don't think I'd really be super mad about having the video. Yes.
Can I have the paper?
Yes.
Can you give me this one?
This isn't one I gave you the other day?
Can you shut up?
Hey,
Mr. G, she's being rude.
put it down.
Put her in her place.
Your service
Put
in the
her in her
world.
I said
place.
harsher.
Kayla, you're welcome.
Thank you, Mr. G. I really appreciate it.
You know what it is?
That was very
All right.
sarcastic.
Okay,
Of course.
so getting back to the curriculum here after that little sidebar. So we had so Kaylee was really a great student today. She mentioned the +1, +3, +5. Oh man, that was a gut punch. That was a gut punch. All right. And so applying this principle here, what were we going to have? It's going to be what?
0.5.
Plus 1/2.
Yeah.
Or Angel says 0.5 plus, you want to say 1.5
Yeah.
and plus 2.5. And so now, what is our vertex going to be?
-2, -3.
So vertex is going to be x is -2, y is -3. And so we can just go like this, right? X h of x. Kayla, does this have any faint recognition to reality for you?
Nope.
Okay, you missed a day of key instruction on this, what amount to. Okay, so what goes here? -1, 0, and 1, right? And up here goes -3,
-4,
-5. And then here we have the plus 1/2, or plus 0.5, I'll keep it the way Angel said it. So this is going to be what? Negative 2.5. And this one here is going to be plus 1.5. So -1, right?
Yes.
And then plus 2.5.
1.5.
So this will be 1.5 here. And then this will be the same thing but the other direction. Okay, for what I want to do for Kayla's benefit and for anybody else who's interested is what happens, Kayla, when we graph a quadratic function, like this parent form of quadratic function, it looks like this. Okay, you have 0, 0, 1, 1, 2, 4, and 3, 5. Does that look right? And then on the other side, because of symmetry, you have this looking thing here. And so these things here, you have +1, and between these next two things, you have +3, and the last one you have +5. Do you see that, Kayla?
Mm-hmm.
Yeah, and so what happens is this creates a pattern, but in this case, what we're doing, and Kaylee, thank you Kaylee again, mentioned this, and then Angel and whoever else multiplied by A, so A equals 1/2, so that changes our pattern in this instance to 1/2, 1.5, 2.5. And so that's what we add here. Do you see that, Kayla? We add this subsequently, and then we add the same thing on the other side. So that's what this is all about. Does that make sense to you now? Okay, good. You know, when somebody misses class. And so now we can easily graph this thing, I hope. So we have our vertex, -2, -3 down here. And then we add 0.5, we add 1.5, and we add 2.5. And then we have our axis symmetry is x equals -2. And then we come the other way, reflected like this. And so sketching would look something like this.
Just like that.
That's what you got? It's because you're a quadratic a function graphing genius. That's what it is, right?
No, calculator.
Oh, you're a calculator using your calculator operator. All right. Okay. Any questions about this one? All right. I may just have you go to. Yeah. Let's not worry about 22. This is just what this is. This is going to be 3. So instead of, and it's plus, so it's going to be -3, and then let's see, 4 times 3 minus 12, and then what's 5 times 3? Wait a second, I got it wrong. 9 minus 9 minus 15. You see that pattern? It's because instead of +1 plus, so you just have that kind of pattern, and then it would look something like this. And you wouldn't even be able to graph it all. It would look something like this. So you take this +2 right here, right? That's going to be -2. And then you'd have -3, -9, and then -15. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you'd have to go down 15 more, which is way out of the scan. So, and then the other side is going to look like this. So you get a really long, skinny parabola is what you get, like this. Something like this. And Kinsey, did you graph that in the calculator?
Yes, I did.
And that's what it looks like, right, Kinsey?
Yes, it does.
All right, Kinsey. Thank you, Kinsey. And so that's that one, right?
Right.
Pretty simple, right? Too simple
Yep.
words? All right. And then really what's happening on these other ones is that even 23 through 26 are even simpler because you're just identifying the vertex and the axis of the graph. So for 23, for instance, what is our vertex going to be?
1, 5.
1, 5. Okay, who said that for us here? Emily, very good. And our axis symmetry is going to be what?
1. X equals
X equals 1. Okay, thank you, Angel and Emily. Good job. And that's it. And similarly for 24, 25, and 26. So you can just write them down, right? And 26 might throw you off, but this one, what do you get for your vertex here?
-1, -1.
-1, -1. Okay. What do you get for your vertex here?
1, -7.
1, -7. Thank you. I recognize that voice. And this one here, our vertex is going to be
3.
square root of 3, 4, and then our axis symmetry, x equals square root of 3.
What about the square and cancel out?
What's that?
I thought the square cancels with the square root.
Oh, no, it wouldn't. I'll tell you why. Because if we had this, Angel's saying this, right? Here, he's right, it would cancel out here. But you can't cancel that out because it's parenthesized in here with this x minus. So that's why you can't do it. Was that your question?
Yeah.
Yeah, yep. Okay, good. So you really should be finished with that. That's all the mileage I want to get out of this one. I want to give you something else we're gonna go with today. So I want you to turn this one in at the end of the day. And we're gonna start on this new one here, which would be exercises
Okay.
33 through 38. Okay, good job. Good job.
Yep.
So Dean, how many papers do you think we do in a whole year?
Enough.
Dozens. I don't know, it's gonna be probably be a month. What? It might be a month
There's 2
or it's not that close to it. Yeah, really, if you really think about this year compared to last year, we're going through more papers this year, aren't we?
Yeah.
What's one reason? The assignments are a little shorter. And really, compared to last year, I kind of like these better because they're just, I think they're more bite-sized for a 45-minute class. In general. Now, the other book has some strengths too, but I've been used to this book for a long time, so I don't know how many years. Okay, what I want to do is go to this one right here. Good afternoon, welcome to room 15 where learning comes first. Yes. Okay, I will tell her. You're welcome, Mother. Yeah. video coming out tonight.
It's gonna come out tonight. I think
Tonight,
I'm gonna need
a little
help
after
on
5
these.
o'clock,
Yeah,
yeah.
I remember it's.
Especially when we're gonna be talking about completing the square. And completing the square is one thing that we've done last year. Does anybody remember anything about completing the square last year?
Kind of.
Emily remembers a little bit. What's
I
that?
remember the box.
Remember the box,
In the X.
the X and so forth? So we're gonna go ahead and review that. And we didn't spend very much time at it last year, so if you don't remember it, I definitely understand. What you do here is you're gonna take f of x, and you're going to try to rewrite this in what you're doing, completing the square. You're going to transform a standard form to vertex form. And why would you be interested in converting to vertex form?
It's easier to graph.
It'll be a lot easier to graph. Exactly. Angel just said easier to graph. That's the main reason, I think. Okay, so now we're going to go ahead and convert this standard form, and everybody recognizes that's a standard form
Yes.
rendering, okay? And so what we're going to do is we're going to open a parentheses here and put x squared right here and put minus 4x. And then we're going to leave a blank here. We're going to say plus blank, and then we're going to have over here like this, and we're going to have minus blank, and then the last thing we're going to have is plus 6. Okay? So that's just kind of the setup for completing the square. And so what we have to do is place a number in here that is going to make of this expression here a perfect square. How do we determine what that number is? Does anybody have some kind of instinct for what that number might be? Or idea?
What number?
What number goes in here to make this a perfect square?
6. Just kidding. I don't know.
No,
Seven.
no.
Is it two numbers that
2 and 3.
multiply to get 6 or multiply to get?
Okay, I'll tell you how to find what it is. What you do is you take, I'm just going to do the little sidebar down here. You take this middle coefficient here, so I'm going to take -4 and divide that by 2. And what do you get out of that? -2. And then the next thing you do is you take that -2 and square it, and what do you get for that?
4.
4. So 4 is the correct number that goes here. Okay? So you follow this formula for it, and then since we added 4 here, what do we have to do here on the outside?
Subtract.
We have to subtract 4. So you have to go ahead and subtract the same thing that you added. And so now we have it set up that we're able to convert this into vertex form. So what is this thing going to be factored out here?
X. Yeah.
X minus 2, X minus 2. And what do we have on the outside now?
One of the base things is x minus 2 squared.
Yeah. What is this 4 and 6? It would be plus 2. So now what we have is f of x equals, as Angel said, thank you Angel, quantity x minus 2 squared plus 2. And so now this is our vertex form. And has anybody in your calculator graphed both of these to check if they're the same? Because that'd be an interesting thing to do, because maybe not interesting, but be helpful on a test, for instance, right? That you see you get the same thing, because you should get the same thing if you converted properly, right? Yeah, Emily's checking. Adam's checking.
Yeah, you do.
Yeah, so Emily gives her seal of approval on this. And then we say, use square, describe the graph of each function. So this, I would describe it as y equals x squared, translated which way?
To the right, wait, to the right to,
Right 2 units
turn up to.
and up 2 units. All right, so does that look pretty good right there? Okay, what I want you to do is try to go ahead and work on 34, which is a similar type of problem. Pardon me? Did you do that already?
Yeah.
Yeah, I'll just take a look at it. Yeah, I think that's right. That looks right to me. Okay, so you did this one here. You finished with that? Okay, you have the other exercise. You got this one here. Or need all of these things here, or you still want to work? Just go ahead here. Okay, what I'm going to do now for number 34, I'm going to go down and put Angel's answer there. And I'm not 100% sure Angel was right, but I think is. So what Angel got was g of x equals x, quantity x minus 3 squared plus 3. Does that look right? Emily's nodding. Right, anybody else?
That's what I got.
Emily, did you get that? You're still working on it? Yeah, see if you can work on it. Anybody else, you get that, Adam?
I'm not done yet.
You're not done? Okay. Well, Angel, I'm telling you one thing that's really good this year is you taking pre-calculus. I wasn't 100% sure you would, but I'm really glad to have you here. Yes, yeah, I did. Yes,
On 35.
on 35.
Did you have any, multiply by -1, will that affect the answer?
Yeah, number 35, this negative thing has kind of a complication here. So I'm gonna let 34 ruminate for a little bit, and I'm gonna come and help out and talk about 35 a little bit, okay? Will that be all right? Let's just give this a little time. Right? Okay, so are the rest of you finished on this one now? Carmen, you got it? Did you get the same answer, Carmen? Or Kinsey, you got it too? Okay. Anybody have any questions about this one?
No.
Not really. Did you get this, Emily? Okay. But for the sake of continuity for the video viewers, I'm going to go ahead and do this anyway. G of x is equal to, same process, we have x squared minus 6x, and that's going to be plus something we don't know yet. And then we're plussing here, so I'm going to subtract the same thing here, and then plus 12. And then down here, the number we have negative 6, which is that coefficient here, divided by 2 equals negative 3. And if we square that negative 3, we get 9. So 9 is the number that goes here. And since we've added 9 here, we have to subtract 9 here. And so we end up with g of x equals quantity x minus 3 squared, and then we have negative 9 plus 12, which is plus 3. So that's really it. And then so to describe, this is what? Y equals x squared, translated which way?
Right 3 units
Right 3 units.
and up 3 units.
My pen is getting a little glitchy. Up 3 units. Man, this thing. Yeah, so anyway, these would be our answers. Okay. Any other questions about this one? Ready to go on to 35? 35 raises a level of complexity that was not seen in 33 or 34. So I want to address that right here. The first thing I want to do to this one is what?
Flip the finger.
Put it in.
Yeah, so you couldn't see what Emily was doing here. She was doing something like this, right? Something like that. She did it better. But what she's trying to say, correct me if I'm wrong, is to change this into standard form, right? Yeah, so she nods her head, she is. So we're going to do that. So we have negative x squared minus 16x plus 10. Okay, one thing that really is going to complicate our lives is that negative x squared. We could deal with a negative 16x, but this negative x squared can be a...
Flip all the sides?
Yeah, is that you, Hannah, who said that?
Yeah.
Yeah, so Hannah, the quadratic function genius back there, is saying flip all the signs. But to do that, we'll just bring this negative sign out front and just rewrite like this. And then that's going to be plus 16x, right?
Minus 10.
And then minus 10. What I'm going to do here, yeah, I'll leave it at minus 10 like this. But what I want to do is take this minus 10 out here instead. But out here, is that going to be minus 10? It'll be plus 10 because we won't have this sign. So because what do I want to do here? I want to leave a blank, right? So what we're doing is we're just flipping the signs here for these two and just leaving this blank, and then we have another blank that goes over here, right? Okay, so now we've kind of re-engineered this one, okay, and then what number is going to go in here?
64.
64, so Angel, and who else said that? Anna. So 64 goes here. How did we get 64 here?
Divide 16 by 2 and then square 8.
Okay, divide 16 by 2 and then square it to get 64. So what's going to go out here?
64.
So 64 is plus or minus going to go out here? Minus 64.
Or would it be plus since you're, I don't know.
Now here we are subtracting 64, right? So we're going to have to add, aren't we?
Yeah.
So that's going to be negative. What's going to go here? X
Where's the y is it from?
Plus 8.
plus 8 squared plus, what goes out here? 74. So that's going to be f of x. So we will say, how do we say this? What are the things that we do to describe the graph here?
Translated.
First thing,
The x-axis.
okay, y equals x squared is reflected
Yeah.
about the x-axis, right? Then what?
I don't know, maybe it's not confusing me.
Translated left 8 units,
And up 74.
up 74 units. Okay, so that's that one right there. Who else got that besides Angel and Hannah? Everybody? Anybody else? Kaylee, good job. So that, you can see that does introduce a level of complication for us, doesn't it? Okay, tomorrow what we're going to do is, I know it's completing the square. We're going to go ahead. I'm going to show you yet another way that's pretty good. I'm looking at these other ones. Yeah. So we'll just go to there. We're about out of time. Thanks, class.